Hi, we're going to be starting a new unit, and this unit is dealing with transformation. But before we even get into transformation and types of transformation, we're going to do a little review of lines in the coordinate plane. So the objective is, how do we find slope and use it to determine the relationship between lines, and how do we write equation of a line in slope-intercept form and graph lines. So this is stuff that you've learned in algebra, when you took algebra. So we're just going to do a refresher so that way you remember it, because it's going to be used especially in geometry. All right, so definition for slope, the definition and formula for graphing. For definition, it is, oops, let me write pen. It would be the rate of change when you're talking about slope, the rate of change. With the formula, it's M represents slope, and you have delta y over delta x. And when you expand on the delta y and delta x, it's y2 minus y1 over x2 minus x1. And it's not the same. When you have slope, you don't write it as y equals mx plus b. That's the equation of a line, not y equals mx plus b. So it's y equals delta y over delta x. And when you graph it, when it comes to looking at it in a graph, finding the slope in a graph, it's rise over run. So 3 ways to represent slope. For definition, it's the rate of change. Formula, m equals delta y over delta x. And when you're looking at it on a graph, you find the rise over run to get your slope. All right, so we have a few examples that says find the slope of the lines below using the slope formula. So since we're looking at the slopes, the lines on the graph, we're going to use rise over run. So for this one, we have our 2 points, and I'm going to put my formula. Oops. Let me undo that. Okay. Delta y over delta x. So now we want to know, how did I get from this point to this point? So I'll count 1. So we do rise. 1, 2, 3, 4. So I went 4 up. And then from there, 1, 2, 2. So then I can simplify it, and my slope is 2. Let's look at this. Again, rise over run, delta x over delta y. And I'm going to put rise over run too, because it's the same thing. So my rise over run, let's look at my rise. I went 1, 2, 3, 4, 5, 6, 7, 8. I went 8, and I did not go anywhere left or right on the x-axis, so it's 0. So then when you look at that, 8 divided by 0 is going to give you undefined. So anytime you have a vertical line, because you learned about that, it means undefined. Okay, the next one, we have, I'm going to put rise over run. If you want to use delta y over delta x, that's fine, but with graphs, let's just use rise over run. So let's see, to get from here to there, so let's see, we went 1, 2, actually no, sorry, not 2, 1, so -1 down, and then 1, 2, 3, 4, 5, 5 to the right. So our slope is -1 over 5. Or if you were to put it in decimal, it would be -0.25, but when it comes to slope, leave it in a fraction. That's the best thing you could do, just leave it in a fraction. And then for this one, let's do rise over run. All right, so we actually didn't rise anywhere, so it's going to be 0. And our run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. 0 divided by a number, 0. So it's a 0 slope because it's horizontal. All right, so that was a review of finding the slope using the graph. Now the summary, it says with positive slopes, lines with positive slopes are always rising. That means you're going up. Lines with negative slopes are always falling. So decreasing, they're going down. Lines with slope of 0 are always horizontal. And then lines with an undefined slope are always vertical. So I'll just put that, and then I put the line that way. Okay, so that was a summary of what we just did. Next part, we're doing investigation of parallel and perpendicular lines. All right, so we have a graph, we have different lines, and with their coordinate points. So they're asking us which line are parallel. So you look for two lines that never intersect, and that would be line M, and L. Which lines are perpendicular? We have two pairs of them. We have N and L, so N and L, and then the other one is M and N. All right, so it said find the slope of each of the lines below, well, to the right. So the slope of line L. So if we look at that, notice that there's 2 points, so we can use those 2 points to find our slope. And since it's a graph, we're going to use rise over run. So I'm going to write that and look at my rise. But since I have to get from here to there, I'm going to go down 1, 2, 3, 4. So that's -4 over 1, 2, 3, 4, 5, 6. So it's 6. And by looking at that, it's a negative slope. So I'm going to put negative. Now for M, same thing. We're going down 1, 2, so it'll be -2 for my rise. And then 1, 2, 3, 3 across. So it's also negative. And let's look at line N to get from here to there. So I went 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 up. And then make sure I was 1, 2, 3, 4, 5, 6, 6 across to the right. And that's positive. So looking at the numbers, we stated that the lines, we said that M and N are perpendicular and L and N are perpendicular. Let's look at the numbers. If we were to reduce this, so let's say have 3 in common, so it'd be 3 over 2. And then we have this one -2 over 3. And then we have -4 over 6, which can be reduced to -2 over 3. In order for lines to be perpendicular to each other, they are opposite reciprocal. That means this one was -2 over 3. The opposite in the reciprocal is 3 over 2. So yes, that means these lines, M and N and L and N, are perpendicular. So for summary, if two lines are parallel, if and only if they have the same slope. If they have the same slope. And two lines are perpendicular if and only if they are opposite reciprocal. Make sure oops, that was weird. Let me write that much neater. Go back to the pen. Reciprocal. So basically you're flipping the fraction and then you're negating it. All right, next one. Practice. So we're going to practice. So the first one, they say determine whether AB and CD are parallel, perpendicular, or neither. All right, so before we do anything, we need to find the slope of AB and then CD. Since they give us 2 points, we're going to use delta y over delta x. So I'll do M. This is for AB. So remember delta y, I'll just write it delta y over delta x, which is y2 minus y1 over x2 minus x1. So now we're going to look at our points, and what I'm going to do to make this easier, I'm going to label x1, y1, x2, y2. So again, you know what points you're going to, what coordinate points you're going to use in order to plug it into the formula. And go back to purple. Right, let's begin. So 7 minus negative 5 over 4 minus negative 2. Notice that I put the negative numbers in parentheses, so that way I don't forget that there was a negative, then a minus sign in front of it. So then this will distribute, this would be 12, and then this distributes, you get positive 2, and then it'd be 6, and then you can simplify it to 2. All right, so that was for AB. Let's do CD. CD, same thing, you know, the x1, y1, x2, y2. So now we have negative 2 minus 2 over 8 minus 0. And that gives us negative 4 over 8. And then when you reduce that, that will be negative 1 over 2. So now, is this perpendicular, parallel, or neither? Let's look at this. We got 2 for AB, and then we got negative 1 over 2. So if you remember, perpendicular is opposite reciprocal. So this is perpendicular. All right, next one. Let's do this. Let's see if it's parallel, perpendicular, or neither. So I'm an AB, it's using the formula that over here, and then making sure that I put my negatives in parentheses and putting everything in its right space. Okay, so then this would be positive, this would be 3, and then this would become positive, and then this is 12, and I can reduce it to 1 over 4. So for CD, 7 minus negative 5, and then over 1 minus negative 2. All right, let me make sure that I separate this. All right, and let's continue. So then this will give me 12 over 3, which is 4. So if you look at this, this one's 1 over 4, and then this is 4, or you could say 4 over 1. It flipped. You might think, oh, it's perpendicular. No, it's not, because it's not. One of them has to be negated in order to satisfy the perpendicular rule. So it's neither. And it's not parallel because we don't have the same slope. So it's neither for this one. All right. Now let's do the last one. We got the slope of AB. So we got negative 3 minus 2 and 6 minus 4. So this will become negative 5 over 2. And then for CD, we have 10 minus 5 over negative 3 minus negative 1, which gives us 5 over negative 2. Are they the same? Yeah. So that means they are parallel. All right, so that's how you determine whether two lines are parallel, perpendicular, or neither. All right, let's move on to the next one. Graphing lines, and we're dealing with the slope-intercept form. So with the slope-intercept form, we know that it's y equals mx plus b, where m is the slope and the y-intercept is b. B tells you where you begin, where you plot your point, and the slope gives you the direction from that point you plot. So looking at the different types of equation, when it comes to writing the y-intercept, we have to write it in coordinate form. So I should also put as the 0b, same thing. For this one, the y-intercept, we look at what's behind and make sure whatever sign is in front of it has to be attached to the number. So we have 0, 4, and the slope, we do it in fraction. So I should put like this. It would be 2 over 1. For this one, the intercept is 0, 7, and the fraction is 1 over 1. I mean, the slope is 1 over 1. The y-intercept, we don't have one, so that means it's 0, 0, 0. And then the slope is negative 3 over 1. Y-intercept is 0, negative 3. There's a negative 3 in front of the 3. A negative in front of the 3. And then the slope is negative 1 over 1. All right, be careful. This was switched. So then our y-intercept is negative 0, negative 3. And the slope is 2 over 1. And same thing, our y-intercept is 0, 8. And our slope is negative 4 over 1. Not too bad. All right, so steps for graphing lines in slope-intercept form. You have to determine the y-intercept. Determine the y-intercept and write it as a coordinate, as coordinates 0 and b, meaning whatever that intercept is, the value. And then determine the slope and write it as a fraction. So you would have m over 1, whatever m is. Then draw a point at the y-intercept. That means your b tells you, your y-intercept tells you where you begin. And then use rise over run to plot your points to plot more points. Your slope will tell you how much you go up or down, or left and right, left or right. And then you connect them with a line, and of course, put your arrows and label it because it's a line that continues forever. Okay, so we're going to just do some examples based on graphing using the slope-intercept form. So it says graph the line with the equation y equals 3x minus 4. So we know the slope is 3 over 1, and the y-intercept, which is our b, is 0, negative 4. So b, our y-intercept, that's where we begin. So I think b is where we begin. So I put my point there, and I'm going 3 up and then 1 to the right. 3 up, 1 to the right. Plot as many points you can plot, and then once you do that, then draw your line. So I'll have my line, and then I put my arrow on both sides, and of course you label it. Always label it. You remember that in algebra, because if you work with more than one line, you need to distinguish the lines. All right, so graph the line with the equation y equals negative 3 over 4x plus 4. So our m is negative 3 over 4, and our b is 0, 4. So I'm going to plot that point, 0, 4, and then I'm going 3 down, 1, 2, 3, and then 4 to the right, 1, 2, 3, 4. I can't go any further, can I? No. So then I go 1, 2, 3 with opposite of negative 3 and 4, positive 4. So it's 3 up, positive, 1, 2, 3, and then 4 to the left, which is negative 1, 2, 3, 1, 2, 3, 4. All right, and I draw a line. Have my arrows, and then I label it. So in this situation, you got two different graphs. You need to label it so we know which one is what. X plus 4. Okay, there you go. All right, so now it says when lines are not in slope-intercept form. So when you don't, before you graph, you need to have that y equals mx plus b format. And in order to do that, basically, it's like you're solving for y. So I'm going to put 4x plus 2y equals 10. You subtract 4x on both sides, so you got 2y equals negative 4x, and then you divide by 2 because you need y to stand alone. And then you got y equals 5 minus 2x. Basically, I divided 2 into to each of the terms, and that's what I got. So then my m is negative 2 over 1, and my b is 0, 5. So I plot that, 0, 5, and the same thing, got negative 2, 2 down, 1 to the right, 2 down, 1 to the right, 2 down, 1 to the right. I think that's enough points. If you have 3 points, then you should be able to connect them, and then draw your line, and then label, of course. So I'm just going to do this one because this is the same thing. And when you label it, stick with the original. Whatever you started with is the label, the equation that you use in order to label the line. So like I said, I'm not going to do this one. This is the same thing. You just turn it into y equals mx plus b, and then plot it, connect it, label it, and there you go. All right. So with this is graphing exceptional lines. For this one, it says horizontal lines intersect at the y-axis. So if you were to graph the line y equals 3, we don't have vx, so this one, yeah, so it's think of y equals mx plus b. Our slope would be 0, 0, and our slope is 0, and our b is 0, 3. So we got 0, 3, and then remember about horizontal lines, the slope, it's a 0 slope, because if your slope is 0, then your line is horizontal. So I'm going to draw that, and then of course put my arrows and label. So then I'll have y equals 3. And then vertical lines intersect at the x-axis. So for this one, that's supposed to be an x. That's a typo. So we have x equals negative 5. So we look for negative 5, and then it's going to be a vertical line. So then use my line, and then again, arrows and label. So remember, horizontal line is 0 slope, and vertical line is undefined. So this would be x equals negative 5. All right. So there's different cases when it comes to writing equations of a line, and we're going to do the first one. It says the given a slope and the y-intercept. So when you're given that, the steps is you determine the slope, determine the y-intercept, and then plug it into the y equals mx plus b. So for this first case, they give us a slope of negative 4, and then the y-intercept, which is b, is 1. So you just use the y equals mx plus b, plug in the information you've got, negative 4x plus 1, and boom. That's it. That's the easiest case because they gave you m and b, you just plug it in. Next one, it'll be a slope and 1 point. So if you have that, you plug the slope and the point into the slope-intercept equation, solve for y, the y-intercept, and then you plug in the slope and the y-intercept that you found into the equation. So they want us to write an equation. They gave us a slope of -1/2, and then they gave us a point, which I'm going to put our xy, which is 4, -7. So again, use the y equals mx plus b, plug in information that they gave us. So we have our x and our y and our slope, and we're going to solve for b. We need to find b. So again, you simplify. This would be -2, and then our b will equal -5. So once we find that, then we use the y equals mx plus b again, and then plug in our slope and our b. So with that, I'm going to use another color. So y equals -½ x plus or -5, or you can just put y equals -½ x minus 5. Either way is fine. Okay, third case, given 2 points. So if they give you 2 points, you need to find the slope, then plug the slope and one of the points into the formula, solve for the y-intercept, that's b, and then plug it into the formula, the m and the b into the formula. So they gave us our 2 points. So I'm going to have x1, y1, x2, y2. I need to find the slope. Remember, slope is delta y over delta x. And so that means it's y2 minus y1, so 2 minus 6, and then over x2 minus x1, 3 minus -3. Simplify, get that, and then our slope is 1. Okay, so we got one of them. Now we have to choose whichever point. We choose point A or B. For this one, I'm going to choose the first one, A, and then I'm going to put y equals mx plus b, then plug in my y, which was 6, and my slope, which I found, -1. My x is -1, and I'm going to find my b. So then this goes that, and solve it, and your b will be 5. Now, I'll just change that. Use that final answer. So I have y equals mx plus b again. Use my slope and my b. So y equals -x plus 5. And that's my equation based on 2 given points. And the last case, there you go, when given an equation and 1 point on a new line. Okay, so the steps are: use the slope of the given equation to determine the new slope, plug in the new slope and given point into the y equals mx plus b, solve for the y-intercept, and then plug the slope and the y-intercept into y equals mx plus b. So it says write an equation in slope-intercept form of a line containing 2, 0 and is perpendicular to the line y equals -x plus b. All right, so using that y equals -x plus b, I know that I look at the slope. The slope is -1 over 1. Now, they say perpendicular. So now, the new line that I have to find is perpendicular to the slope. So that means it's going to be 1 over 1, but positive. So it's a negative reciprocal. So that means this will turn positive. So the new slope will be 1. So now I'm going to use that slope, and I'm going to use the point that's going to be for the new line. So I do y equals mx plus b. I have my y, 0, my m, 1, oops, and times 2. So then I got that. I simplify. My b is going to be -2. So now I use these two to give me my new line that is perpendicular to the line that they gave us. So it's y equals x plus, oops, x minus 2. I could put x plus negative 2, but I'm just going to simplify that and give me, where is that, x minus 2. And that's my line. That is perpendicular to this line because it's opposite reciprocal. All right, so that's a review, a recap of lines in a coordinate plane. This is stuff that you learn in algebra. So like I said, this is a refresher because you're going to see this later on in other units. And perhaps this chapter, this unit 2. And yeah. So this concludes our review lesson. Have a good day.